Okay, so problem 3.39 says the ammeter in the circuit has a resistance of 0.1 ohms. So we use the definition of the percentage error in the meter read found in problem 3.38. What is the percentage error in the reading of this ammeter? So if we go back to 3.38, I'll write this down. We see that percentage error reading is this. It's going to be the measured value over the true value. Minus 1 times 100. Yeah, so let's go ahead and find so our measured value. So our measured value, we're going to account for the resistance of this ammeter, which is 0.1 ohms. So we can just say I'll do the universal method. Yeah, this is going to be our ground. Okay, so go ahead and say IS, I1, and then I2. Right, so I'm just gonna sum these, make them one resistor and call it 20.1 ohms. So I'm gonna write the KCL. KCL is IS equals I1 plus I2. And then EFC is gonna be I1 equals, oh, I forgot to label this. I'm gonna call this 50 volts V1. Yeah, so I'm going to call this I1 equals V1 minus 0 over 60. And then I2 is going to be equal to V1 minus 0 over 20.1 ohms. Right, and so we want to find IS, which is our initial current, right? So it says use the, yeah. So let's plug this into Maxima. We have three equations. Plus I1 plus I2. 1 is equal to V1 over 60, and then I2 is equal to V1 over 20.1. And then we have our variables would be IS, I1, I2. You can also say V1. Oh, we forgot, yeah. So we forgot one equation. So we can just write it here. We say IS is equal to 50 minus V1 over 10. I believe that should fix it. No. Oh, there. The comma. Nope. Let's copy and paste this. I don't believe this is wrong. So restart Maxima, no connection. So before I do that, I'm gonna just write this equation. Cool. So then I want to find I2. 1 plus I2 equals over 60. I2 equals V1 over 20.1. And IS equals 50 minus V1 over 10. And then the variables would be IS, I1, I2, and V1. Cool. So our reading for I2 would be 1,000 over 669. So 1,000 over 669 would be, yeah, let's call this, yeah. Let's say, I measure I2 is 1,000 over 669. That's going to be 1 point something, something, something. So then this would be our measured value here. For our true value, we don't necessarily account for the resistance that the ammeter gives us. So we would just say, we would do this exact same, we would plug this exactly the same, except for instead of having 20.1, we would just have 20. So I can just go ahead and just copy this, plug this back down here, and then I just take out the 0.1 and boom. Our I2 would be, would it be, wait. Let's, I'm gonna double check this. Yeah, so yeah, so I believe, yeah, I2 is gonna be 1.5. So our true I2 would be 1.5 amps. This is also amps. So we use this. So we say, I'm gonna do it in blue or green. Measured value, which is our percent error, would be 1,000 over 669. Oops. Times, this is 3 over 2, right? So you can just say 2 over 3 minus 1 times 100. I'm going to do that in my calculator. 1,000 over 669 times 2 over 3 minus 1. Here, let me figure that out. So that would be negative 0. Yeah, times 100. So we would get this. We would get percent error is -0. Well, yeah. So a reading would be -0.34878 if I would round it off there. Yeah. So this would be our approximate to a percent error. We can also say our percent error is 3.5 or 3 or -0.349. Yeah, but any of these values would be considered correct unless yeah. And yeah, that's 3.39.